Hello everyone! We will discuss about rational inequality today, and let's see what is the overview of this chapter. First, our learning objectives. In this lesson, you need to demonstrate understanding of key concept of rational functions and accurately solve real-life problems involving rational function. Before we continue to the lesson, you need to review some pre-knowledge topics. The first one is about rational function. So, a rational function has the form of fx equal px over qx, where p and q are polynomial functions. So this is the example of a rational function and the graph. Please recall that in this kind of function, you will see a vertical asymptote at x equals -1 and a horizontal asymptote at y equals 1 for the graph of fx equals x minus 1 over x plus 1. Another topic that you need to review is about linear and quadratic inequalities and how to solve the inequality. For example, we have fx equal x squared minus 2x minus 3. We know that this quadratic function has a form of parabola which has the zeros of -1 and 3. So when fx less than 0, we have the interval. We know that in this interval, the value of fx are negative, and in this interval of fx, the value are positive. So we make a number line and have the sign for x less than -1, it is plus. In between -1 and 3, it's negative. And larger than x equals 3, it's positive. So we will take the function value that is negative, that is between -1 and 3. When fx greater than 0, fx greater than 0 at two different parts or area, that is x less than -1 or x greater than 3. So let's see now the example of rational function in real life, that is a medical example. You know that before surgery, a patient might be injected with some medication. Then, when the concentration of the drug in the bloodstream is at a desired level, the operation will begin. You can model the concentration of the drug in the patient's bloodstream using a rational function. Here is a rational function representing the concentration of a drug in the patient bloodstream. Ct equals 4t over t squared plus 2, and this kind of graph will be obtained. Being able to analyze this rational function can help a nurse or doctor determine when the drug will wear off on the patient. Let us analyze the graph by answering the following questions. What is the highest level of concentration Ct of drug in the patient's bloodstream, and when it happened? What is the concentration Ct after 10 hours? And after 5 hours, when the concentration Ct less than 0.2 mg per milliliter. So you can pause this video first while you think about the answers. So, what is the highest level of concentration? This will be the highest level, 1.4 mg per milliliter. When it happened? We can see in here, the time in having the concentration of 1.4 is 1.4 hour as well. What is the concentration Ct after 10 hours? Please take a look here that when t equals 10, we have the concentration starting from 0.4 and it will be decreasing to a certain value. And after 5 hours, let's see here, when the concentration Ct less than 0.2. So let's take a look at the right parts of the graph that it is already after the 5th hour. And when the concentration is 0.2, we can read from the graph that in here, the time will be larger than 20 hours. We write it down as t greater than 20 hours. Now, please think about these problems. We already know how to solve the inequalities using graph, but how to solve rational inequalities using algebraic methods? Are there any common methods in solving quadratic inequalities and rational inequalities? So let's continue how to solve these problems in our meeting. That's all for this video topic. Goodbye everyone, God bless you all, and stay healthy. Bye-bye.